Oh, funny story about that black hole. They created a brand new rendering engine to create that black hole as accurately as they could.
This is an Interstellar?
This is
Yes.
an Interstellar. That's
Oh.
why the black hole in
I thought you were talking about
Interstellar
the image of the
looks like the image that we
It's
got.
like the most perfectly accurate representation that we have.
Whoa.
They went to like
pretty cool.
physicists and were like, "Hey, like, what's gonna happen?" And then the physicists told them, and they coded a render engine for the scene where they're flying around the black hole with the accretion disk and all of this, and they rendered it. And when they got it, they were like, "This is what we think it'll look like." And scientists used
looks
that.
pretty cool.
Scientists used that for a bit until they got the actual image, and they
Yeah.
were like, "Oh, this is like shockingly close. This is
Wait,
scary."
so the
close."
Interstellar rendering of a black hole was used by scientists as like the best image we have of a black hole until we got one.
Yeah, it was like the best.
Yeah,
That's
visual one.
crazy.
That's
Imagine
really cool.
like being that, like you make a movie and you're like you care that much about it to make it the most accurate. I mean, even like just the money to pour into it, just for that. We're like, who's really gonna notice? That's admirable for sure.
I think Willem could look this up, but I think each like frame of the black hole took like 10 hours to render or something
Yeah.
like crazy.
Because they're doing like, obviously, like when you create something from scratch, it's not going to be the most optimized, but also like it's doing something that computers never did before. They're like trying to model what would happen to all these particles around
Right.
this black hole and then like render it.
Right. It's like my guess is that in 3D space, since we know a lot about it, there's probably some shortcuts that we can take in the rendering process, some simplifications
Yeah.
that we make to make it faster.
Yeah.
But we probably can't do that for black holes because we just don't know. So we just needed to let it like just render it out.
Yeah,
and just,
kind of like brute force. Like
Yeah.
ray tracing used to have to be brute forced by like calculating, oh, this particle is moving to this point, and then it's going to bounce off here,
Right.
and then it's going to go to
Right.
here. And now you have dedicated ray tracing chips in like GPUs that render these things, and those calculations just go through at 1,000,000 miles a second. Because
1,000,000 miles. Is that your final answer?
Yeah, final answer, 1,000,000 miles a second.
All right, we're getting a real time statistic here for interstellar rendering. Okay, so the answer is state of the art server farm, 100 days to render
a lot.
one black hole.
A third
scene.
of a year.
I mean, even just in energy, how that's got to cost a lot. Well, obviously, like not even considering developing this engine from scratch and like
Having to figure out how to code it, how to like integrate it into.
yeah, they probably like visited a black hole and like took some measurements.
Yeah.
Well, that's like, did you guys have space books when you were a kid? Like those books that had all the cool images of space stuff,
Yeah.
like planets. I guess I never thought about it, but when I got older, I realized that none of those were actual images of like black holes and stuff.
all
Like,
the planets
oh
just
no,
next to
It's like
each
that was
other.
Microsoft Paint.
yeah. But no, they looked really realistic. So I don't know. But
Well,
Looks
they
good.
look realistic to you, who had no idea what it should look like.
they
Exactly.
looked pretty good.
Yeah,
My imagination couldn't
yeah.
prove them wrong.
Okay, so we just got word from our PA Chapo. So not only did they have to render the light, like they made it like I guess a rendering engine, as you said, Finian, but they also had to like make their own physics engine because the existing ones just didn't do the right physics that would be applicable in this case.
Yeah.
So I mean, I'm sure a ton of work went into both of those things, which is very cool.
Yeah, I think like I don't know if you've heard of like Universe Sandbox, but like renderings of black holes exist, but they definitely like cheat in like how they do. I don't know like how things are rendered, but I think like this one like they didn't say like, oh, like no light's gonna come out of this. They like put in like a ton of mass and like
Yeah.
this is what it
Right.
it
Like,
turns
they
into
didn't
a
they
black
didn't take
hole.
assumptions, or they probably took very few assumptions.
Yes, exactly.
About, right.
Like they like created a black hole in their simulation,
Right.
and like rendered that.
Could you imagine like hitting go and waiting 100 days and it comes back and you like forgot to like
Oh my
unhide a layer and like you're like
Well, like they definitely, like obviously, like beforehand they were like, okay, we got to make sure
Like,
everything's
are we
ready.
locked in here?
Yeah,
Are we ready to
everything's
go?
ready. Hit go, and they don't know how long that's going to take. Probably.
I'm sure it gives estimates as it goes, but
Yeah. Imagine just seeing that like estimate go up. It's
Yeah.
like, okay, 16 days.
Yeah.
18 days.
Well,
like,
yeah, I'd imagine that they did some small scale testing,
Yeah,
for
probably.
sure. So they have some estimates of like, is this going to be a linear or non-linear thing? Like, what's the relationship between complexity and time and all these things? And I feel like you'd also sort of need like a real time rendering, or at least like every so often get some feedback about what it's doing, because like you press play, it goes 100 days, and you have no idea what it looks like the entire time. Like, I feel like there's got to be.
You can most likely it'll spit out like every time that it gets a frame, they most likely would have it like spit out.
Right.
Like, oh, this is what the frame looks like.
Right, and so you can sort of pause it if it.
Yeah.
I
if
mean,
it starts going awry.